You're listening to Weather with Enthusiasm. Good evening. It is Sunday evening, February 22nd. This is your weather enthusiast, Simcha Lefton, bringing you the latest on a developing winter storm. Very intense. This one might be historical for the East Coast. This has some remarkable features to it, the storm system, which continues to develop on the East Coast, making this very complex for forecasters to forecast. One of them is something called an inverted trough, which is developing and forecasted to develop as we go through the night. The other thing is that the storm is tracking 50 miles further east than what was originally forecasted. Nonetheless, it's expected to reach 40 degrees north latitude, 70 degrees north longitude, bringing very heavy snow to portions of southeast Massachusetts. But it's not just southeast Massachusetts, east central New Jersey. Right around the Lakewood area is the bullseye for this storm, along with southeastern portions of Massachusetts. This storm potentially could have two bullseye. We have a complex situation. The meteorologists from the National Weather Service of New York City have been toning down what the models have been saying regarding snowfall accumulations, while the Baltimore National Weather Service is publicizing that it's going to be a little bit higher than what some of the models are saying. Let's just make sense of this, what's going on right now. The two are not really arguing with each other. What's happening is, on average, the amount of snow that is forecasted to fall might be a little bit less than what some of the models are saying, but the localized totals will likely be significantly higher than what was originally forecasted. Let me just explain this. It's something called an inverted trough. The Baltimore National Weather Service is referring to it as a Norland trough. This because there was a meteorologist with that name, with at least the Lind part, that is the one that noticed these features on nor'easters. It's something like that. So this is a trough that extends northwest from the surface low mesoscale zone of enhanced convergence. It's notorious for narrow, intense snow bands beyond what the global models could resolve, and it acts as a snowfall rate amplifier, which could create secondary band or enhanced primary band. What the thing about this is that it's the opposite of what a normal trough looks like. The normal trough actually dips southward. An inverted trough is something which kind of bulges northward, and it could create a secondary area, a secondary bullseye further to the west than the actual storm system, significantly further to the west than the actual storm system is. This is why Philadelphia has recently been included in warning criteria for heavy snowfall. This is significantly further west than the actual storm system. So even though the storm system has moved 50 miles further east than what was originally forecasted, and by the way, it's also 6 hours faster than what was originally forecasted, there still is this inverted trough, which the Baltimore National Weather Service again refers to as the Norland trough, and that's complicating the forecast in the Baltimore area. Nonetheless, some of the warnings have been lifted in the Baltimore area because of warmer temperatures, so the precipitation did not fall as snow in some locations as what was originally forecasted. Nonetheless, there still remains areas which are under advisories and warnings across the East Coast, even that far down south in Maryland. But as you go further north, this is blizzard warning criteria big time for places in east central New Jersey. This precipitation starts off as rain. It remains rain. This is unique, I think, in many ways. There is a uniqueness to it in the fact that it's starting off as rain. This is something which is probably more common in the Midwest, with the larger snowstorms more frequently do start off as rain. Here in the Midwest, on the East Coast, I've noticed it to be less common. The precipitation is expected to transition to snow really early this evening. Heavier snow moves into the central New Jersey area, probably even as we speak, at about 7 p.m. for parts of the New York City metro. That precipitation falls at a rate as we go through the night. The area which is impacted by this trough could see 1 to 3 inches of snow per hour. The area which is impacted by the actual bullseye from the storm system may see snowfall rates of 2 to 4 inches an hour. That's probably going to happen for portions of southeastern areas of Massachusetts. Here's another thing that's a little bit unique for this nor'easter is that the snow to water ratios are a little bit low for the beginning. It's 10 to 1, tells us the National Weather Service, but they think that might even be overdoing it. It might actually only be 9 to 1. This is a heavy, wet snow to start, eventually becoming 12 to 14 to 1. On average, about 13 to 1 towards the end, 9 or 10 to 1 towards the beginning. So the reason why the snowfall totals are actually so large is because there genuinely is a large amount of QPF, despite the fact that the New York City National Weather Service tells us that the QPFs have gone a little bit down. We're still looking at some really intense stuff of 1.5 to 2 inches of water equivalent with this system. It's something quite intense, and this is also something that could produce power outages due to the heavy, wet nature of the snow. The snowfall becomes more powdery as we go through the night. Here's some other features of this storm system. First of all, it's a major bomb cyclone. It's already dropped 35 millibars in the past 24 hours. The system is expected to deepen to 970 millibars or lower. If you look at the European computer model on windy.com, you'll see the storm system deepening to 28.6. 28.6. This is already in the hurricane strength category. Tropical storm force winds sustained winds are expected with this storm system. We also have another unique thing, something that I have not come across this, so at least it's not so common, which the Baltimore National Weather Service is saying record low tides. Record low tides. I'm going to come back to that in just a moment as to what's happening, because much of the East Coast will be receiving flooding from the storm system. We have the record low tides. We are going to see some very low water levels in some areas of the Chesapeake Bay and other locations around there. We'll come back to that in a second, but I do want to point out that a lot of the big storms happened to have occurred right around the new moon or the full moon in Rosh Chodesh or right in the mid part of the month. It just happens to come out that way a lot of the times, and this enhances the flooding. This storm system is occurring at a time when it's actually just perfect to not produce flooding regarding the tide. The gravitational pull of the moon is least right now. It's the lowest it could be in the month right now, but despite that, the storm is powerful enough to be bringing a very significant flooding risk. So this has the potential to make it into the top 10 snowstorms for New York City. The synoptic weather setup over here is that an upper level trough is digging southeast from the Great Lakes toward the mid-Atlantic area. The trough becomes negatively tilted, and it becomes favorable for the surface cyclogenesis. That's a major feature of pretty much all storms, and that's where heavy snow could form. But there's more variables than just that. The strong Barcelinic zone offshore along the Gulf Stream will be providing the thermal contrast for rapid deepening. Upper trough closes off, height falls exceeds 300 meters, pressure falls accelerate dramatically due to this, and as we mentioned, the storm tracks near the climatological area of 40 degrees north latitude, 70 degrees west longitude benchmark. That's a classic high-impact northeast setup. Despite the eastward shift, it remains headed towards that area, which puts southeast Massachusetts once again at a major bullseye over here. There's 3 interacting mesoscale features which will be driving the snowfall intensity for this storm. Number 1, we spoke about the inverted Norland Trough, which is the National Weather Service of different cities have been using different terms for this. The Mount Holly, New Jersey National Weather Service, that's the one that covers both Philadelphia and Lakewood, New Jersey, refers to it as an inverted trough, but the Baltimore Washington National Weather Service is calling it a Norland Trough. It's actually the same thing. The Boston National Weather Service is referring to the heaviest area of snow as a pivoting mesoscale snow band, which some are saying that it is the same thing. The other major snowfall mechanism over here is the frontogenesis, as we pointed out, a strong low to mid-level frontogenesis along the coastal Barcelonic zone. This will be enhancing the circulation, the forcing ascent through the dendritic growth zone, which is deep, shows deep saturation within the dendritic growth zone, which does support 2 to 4 inches of snowfall per hour. For road crews to keep up with a storm system, it really has to produce less than an inch an hour or once you get to an inch an hour from the various articles that I've read, it becomes very difficult for road crews to keep up with the system. The system has, right now it's still falling as rain in many locations, but and also many of the National Weather Service do not mention the number 4. That's something that when you hit the Southern New England National Weather Service, you start to see the 4-inch rate mentioned. You just have 2 or more inches per hour, which, that could include 4. The band evolution, the initial snow band translates northward with the system. As the mid-level closes off, the band transitions to a pivoting deformation band. Climatologically speaking, along with the computer models, favor southeast Massachusetts for a prolonged band could set up over there. That's really the complication over here, is that we're dealing with heavy snow bands within this inverted trough. The problem with that regarding forecasting is that the global models don't pick up on this, and the high-resolution models do pick up on it, but they're not able to pinpoint exactly where or when or if the bands will become locked in place. So that's why a lot of times in the forecast, you'll hear the general forecast snowfall accumulation, but higher localized amounts. That means that there will be these bands that will set up due to the inverted trough, which brings a lot of moisture westward. It kind of moves westward as well from the ocean. It's the forecast complexities seem similar to lake effect snow. It becomes difficult to really pinpoint it down, but it does seem like somewhere in the Lakewood, New Jersey area, somewhere in those counties, Ocean County, New Jersey, or some of the surrounding counties over there are likely to see this inverted trough bringing heavier snowfall totals to that area. As the mid-level low closes off, the band transitions to a pivoting deformation band. And the pivot point is the axis of the maximum snowfall. Dynamical plus the climatological signals favor southeast Massachusetts, as we pointed out. The southeast Massachusetts remains the bullseye, and that's because it's northwest of the surface low, but southeast of the mid-level low. It's cold enough for snow while within the deepest moisture plume, and it sits beneath the overlap of jet-level divergence plus low-level convergence, and the band pivots. The snowfall rates remain high for several hours. Totals are expected to exceed 2 feet with localized higher amounts, and isolated thunder snow is possible. If there is thunder snow occurring along the coast, that could be an indicator that the main bullseye might actually be associated with the main storm system and not the inverted trough. Here's why there might be 2 bullseye, meaning there might be one bullseye which is super enhanced, or there might end up being 2 separate bullseyes. So the mid-level low closes off, the strong deformation zone, frontogenesis tightens, the band pivots and stalls. That's the primary coastal low. That's what is expected or forecasted to happen. And by bullseye number 1, what we'll see over there is very intense rates with the heaviest totals when the band parks, should that happen. Climatologically speaking, it would be northwest of the surface low near or inside of 40 degrees north latitude, 70 degrees west longitude. So this would favor southeast Massachusetts and parts of Rhode Island as well. And there might be in that area 24 to 30 inches if the band stalls for hours. The other bullseye also, we have parts of New Jersey that also look like they will be included in this, which also could be seeing 24 to 30 inches. The National Weather Service has parts of New Jersey also within this really intense bullseye of 24 to 30 inches. Ocean County, New Jersey, that includes the Lakewood area. Lakewood is the largest populated city within that county. So the bullseye number 2 is associated with the inverted Norland Trough, and this is a sneaky part of the storm. It extends northwest from the coastal low-level convergence, upper support overlap. It's a narrower footprint, and it's undermodeled. Usually, it's undermodeled. Whatever the models are saying, the snowfall will actually likely be higher in this area. The rates of 1 to 3 inches an hour, and that could overperform expectations. And the ideal location for this is northwest of the coastal front, portions of central New Jersey, eastern Pennsylvania, or interior southern New England. And in some cases, this could become the primary bullseye. The National Weather Service, again, their map does include even east central New Jersey. We have Lakewood and Ocean County, a couple other counties, which we're going to speak about in just a second. Ocean County, the National Weather Service in Mount Holly explicitly tells us that localized 24-inch risk is tied to the coastal convergence frontogenesis max. It mentioned Monmouth, I don't know if I'm pronouncing that right, but the Monmouth County, Ocean County, and southeast Burlington as coastal convergence maximized zones. Lakewood's potential is not just from the storm center proximity, but also from the coastal convergence front, and plus an inverted Norland Trough upside. So the axis sets up over or just west or east of town and stalls, then you have 24 to 30 inches possible. Both bullseyes apply, but serve different roles in the same storm. Now, we have a low-level jet, 65 to 75 knots, lifting northward into southern New England overnight. The thermodynamic profile supports efficient downward momentum transfer, and this could produce widespread damage and gusts. There's really no such thing as hurricane-force wind gusts, but that's because by definition, 74 miles per hour means sustained winds. But severe blowing and drifting snow increase power outage risk where the snow is wet and heavy. Ahead of the low, we have falling pressure and strong onshore flow, positive storm surge, coastal flooding at high tide, which is from an inverted barometer effect, and a wind-driven water piling, which could produce flooding. After the storm, the winds veer sharply northwest. A strong offshore flow physically removes water from the bays and the tidal rivers, and a rapid pressure rise reinforces this effect. So this is called a blowout tide, where water levels fall abnormally low, unusually low during the low tide cycles. It's dramatic but well understood reversal. It's a dramatic reversal. The model performance and the forecast divergent. The global models handle the large-scale track and the rapid deepening, but they continue to struggle, and they've always struggled with band placement and mesoscale snowfall maximum. The high-resolution guidance, it picks up on the banding, but it is not able to tell us where this banding is going to happen. And until we have it confirmed by radar, once the radar confirms the band locking and the pivoting, so the snowfall outcomes become, the forecasts become more certain. Where exactly the higher amounts will occur, that becomes more certain. So we have the New York City National Weather Service. They're telling us that the global models are putting too high. They have the QPFs a little bit too high. They've manually adjusted the snowfall downward. So the Baltimore National Weather Service, they're telling us that the models are underdoing snowfall because of the inverted trough. The Baltimore National Weather Service is focused on a different area, and they're speaking about the localized amounts, I believe, and they're covering the Piedmont, Blue Ridge, and interior zones like that. And some of those areas are missed by the global models. The Norland Trough is not well resolved in the global models. Here's some other geographical features that will be impacting the snowfall rates. It's called an orographic enhancement, or also referred to as an upslope snow on the windward side of the mountains. So if the low-level wind is from the east, the eastern slopes are windward, so the easterly upslope, you have heavier snow there. It would actually be the northward the north side of the mountains that would be receiving the upslope higher amounts. The main bullseye is the highest confidence for top totals at southern New England, especially southeast Massachusetts, parts of Rhode Island, especially eastern Rhode Island if the pivot sets up there. The secondary heavy snow zone, narrower, more band dependent, is southwest, northeast, and 10th band tied to the inverted Norland Trough, which can favor New Jersey into eastern Pennsylvania, interior southern New England in some cases. The Monmouth in the ocean and southeast Burlington County areas are favored areas according to the National Weather Service. We have a few more systems which are forecasted to impact the East Coast later on in the week. Another one could bring a couple more inches of snow midweek, and then a more significant storm system towards the end of the week, which could end up falling as rain or at least a rain-snow mixture. But this storm could produce thunder in spots. It's for snow lovers, it's definitely an exciting storm system. We already have many schools that have been called off. I believe all public schools have been canceled for New York City for tomorrow, even remote learning, I believe. And we remind everyone that this snow shoveling is going to be a little bit more dangerous than usual due to the heavy, wet nature of the initial snow. And everyone, stay safe. Look up in your local National Weather Service for all these safety tips, along with any additional updates regarding this potentially historic winter storm. Thank you for listening. Have a wonderful day.